This is a follow-up to a previous answer video I made which explained how to get data out of a closed workbook without having to open up the file. In that video I showed how to connect to one single workbook and extract different sets of data from it. In this video I want to go a step further and look at how to get data from multiple closed workbooks without having to open up a single file. To get started, I've got an almost blank workbook. It's got some column headings in sheet 1, and this is going to be where we'll paste all of the data from the closed files we'll loop over. I've saved it as a macro-enabled workbook, and it's saved in a folder along with a subfolder called My Files, and that's the one that contains all of the files we'll get the data from. Each of these files has the same basic structure. If I just open up one of them to show you what's in there, it's the same column headings in the same order as our main worksheet, but the number of rows is different in each of the individual files. The worksheet name is the same, it's sheet 1 in each file. So to get that to work, let's head into the Visual Basic editor of our main workbook, and I will insert a new module into the project and begin a new subroutine called something like Get Data from Multiple Files. The techniques we're going to use here rely on the Microsoft ActiveX Data Objects library. So before we add any more code, let's head up to the Tools menu and choose References, and then we can scroll through the list to find Microsoft ActiveX Data Objects. You should find several versions of that library installed. I'm going to check the box next to the latest version of the library I have available, 6.1, and then having done that I can click OK, and now I have access to a bunch of extra classes defined in that library which will help me connect to those Excel workbooks. The first object I'm going to create, the first variable I'll declare, I'm going to say dim cn as adodb.connection. So that represents the connection to the files that we're going to create one by one. And I'm going to create a new instance of that connection object by saying set cn equals new adodb.connection. Next, I'd like to connect to a single file in the My Files folder. Let's use Movies 2016 to demonstrate. To connect to that file, I need to know which connection string to use. The connection string is the most important property of a connection object. It contains information such as what the data source type is, where the file is located, any credentials you might need to pass, etc. So to set it in VBA, I can say cn.connectionString equals, and then open and close a set of double quotes. Now, if you're not sure how to write a connection string from scratch, and to be honest, I rarely do that myself, let's head over to the connectionstrings.com website, which allows us to find connection strings for any data source we could think of. You'll get an idea as to how flexible ActiveX Data Objects are. You can connect to almost any data source type you can think of using this same technique, providing you have the correct connection string. So we're going to go for an Excel connection. Let's click on the Excel link over here. Then we need to pick a provider or driver. I'm going to go with Microsoft ACE OLADB, the Access Database Engine. If I click on that, I then get a filtered list of connection strings I could use for various versions of Excel. So it's important, of course, to find a relevant version of Excel. If I start scrolling through the list, I think the last version listed here on this page is Excel 2013. But the one listed for 2013 is actually the same for Excel 2010 and for 2007 as well. The connection string hasn't really changed since the XLSX file extension was introduced in Office 2007. So at this point I'm just going to copy this connection string, head back to the Visual Basic editor, and then paste that in inside the double quotes. I've got a little work to do just to tidy this up and make it readable, so I'm going to start by splitting this onto multiple different lines. Let's use a space underscore character so that we can take this string down to the next line. And then I'm going to identify where the semicolon characters are. That's the end of one particular property defined in the connection string. So the first thing is the provider. And then I'll type in a closed double quotes there and then concatenate that to a new line, beginning a new set of double quotes. The next thing is the data source. We need to change that as well. We'll sort that out in a moment. But find the next semicolon character, close the double quotes, and then a concatenation character, I should say, an ampersand, and then a space underscore before we head down to the next line. Now everything here is specified in a single property, so extended properties tells us that we're connecting to a particular version of Excel and a particular file type. So that's one other thing that's quite important. I'm connecting to an XLSX file. There are subtly different connection strings for XLSX, XLSB and XLSM, so do make sure you get the right one. So the other thing it specifies is that there are header rows, or there is a header row in each file as well. And there's one small problem with the extended properties. Those are passed in as a string within the greater connection string. So you can see I've got a set of double quotes nested inside a set of double quotes. And that's always a bad thing in VBA because you get a syntax error when you try to enter it. So I've got a couple of choices here. I can either double up my double quotes within the larger string, and that will work, although it's potentially a bit confusing to read. So let's change it to single quotes instead. That's also a way to do it, and I think that looks a little better. Now let's sort out the file path for the data source property of the connection string. Just to help me out later on, I'm going to store the path to the My Files folder in a variable. So let's declare that variable first. Let's say dim My Files path as a string. And then, after my list of variable declarations, let's say My Files path equals this workbook.path, and then concatenate to that a backslash and the name of the My Files folder and another backslash. Then I can place that inside the data source property of the connection string. So I'm going to basically get rid of all of this up to the full stop before the file name extension. I'm going to backspace that, and I'm going to type in a double quote and then concatenate the My Files path variable, and then concatenate the extension name as well as the name of the single file we're going to connect to, which was Movies 2016. So in this first example, of course, we're just going to connect to one single Excel workbook, Movies 2016, just make sure I've got that spelled correctly. And then what we can do is test that that connection is going to work. So a simple way to do that is to attempt to open the connection to the file. I'll provide a few blank lines where we'll fill in some interesting code shortly. And then once I've tested that it's opened, I'm going to then close the connection. So hopefully nothing will happen, or nothing obvious will happen when I run this subroutine. If I step through it using the F8 key, if nothing happens, that's a good sign when I execute this line. Excellent, the connection is opened. And if I close it again and then end the subroutine, if anything was wrong with the connection string or anything was wrong with the file, then this line would have thrown a runtime error, but everything's working correctly, so we're good to move on to the next stage. Next, I'd like to try to retrieve some data from the file we've just connected to. And to do that, we need a container to hold all the information we retrieve. And that container is going to be a Recordset object. So let's declare a new variable to hold a reference to that record set. We'll say dim rs as adodb.recordset. After I've created my new connection, I'm then going to create a new instance of the Recordset class. So we'll say set rs equals new adodb.recordset. And then after I've opened up the connection, I'm going to open up the record set by saying rs.open. Now there are a few properties of the record set object I need to specify for the open method. So if I type in a space, the two parameters we're going to set a value for are the source and the active connection. Let's set these on separate lines. So I'll use space underscore and continue typing on the next line. And I'm going to name my parameters just to help me understand what's going on here. So source : equals. And it's at this point where if you know some SQL, some select statements, you're at a big advantage because the source is essentially going to select all of the columns from the worksheet in that workbook. And we're going to do that in a set of double quotes using a select statement, select star or select asterisk. The asterisk there represents all of the columns in the table we're about to reference. And we reference the table by saying from, and then for an Excel worksheet in some square brackets, we can say sheet 1 followed by a $sign. We can then close the square brackets and close the double quotes. So in this example, all of the workbooks have a single worksheet with the same name, sheet 1, so that will work nicely. We'll type in a comma followed by a space underscore, and then we're going to set the active connection parameter as well. So active connection : equals, well, we only have one available. It's called CN. Once again, just before we test this, I'm going to give myself a few blank lines and then make sure that we close the record set afterwards. And just to check that this is actually working, let's use the F8 key to step through. We know the connection works and that opens up. Does the record set open up as well? Well, nothing went wrong, so I'm going to assume that it did. We can investigate some of the record set properties in the locals window if you like, but I'm going to just close down the record set, close down the connection, and then end the subroutine. The final step for this quick test is to write the contents of the record set out into the worksheet before we close it. And this is the easiest part of the whole process. If I simply refer to the top left-hand corner cell where I want my data to be pasted, that's range A2 on sheet 1, I can use a specific method to copy data from a record set. So let's say sheet1.range A2.copy from record set. And there's a single parameter that I need to specify for this method. It's called data as unknown, and it wants a reference to a record set object, so I can simply pass in my rs variable. So at this point, if I run the subroutine, we'll find, sitting from cell A2 downwards, the list of all of the films contained in sheet 1 of the Movies 2016 workbook. Just before we carry on, I'm going to tidy things up a little bit. Of course, in a moment, we're going to try to construct a loop to build up a list of films. And I don't want to just continue pasting into cell A2. I want to make sure that I paste into the next available blank cell at the end of the list. And the technique I'm going to use to do that is to start from the bottom of the worksheet, end Excel upwards, and then offset one cell further down from there. So to do that, I'm going to head back to the Visual Basic Editor, and rather than saying range A2, I'm going to change that to say range A 1,048,576. And then before I copy from the record set, I'll say .end, Excel up, and then I'll say .offset 1,0, .copy from record set rs, and that will guarantee that my list will be built up step by step. I'd also like to test this subroutine a few times, and I want to make sure that I get rid of any existing data from sheet 1 before I begin. So to do that, I'm going to head up to the top of the subroutine and then add a line of code which says sheet1.range A1, and then I'm going to refer to the current region property. So you can imagine the current region, if I have cell A1 selected, if I hit Control A, that represents the current region. I then want to shift that region down by one row and then clear everything from the remaining cells. So I don't want to delete or get rid of the row headings, the column headings I should say. So to do that, current region .offset 1,0, and then I can simply say .clear to get rid of everything. Having done that, I can run this subroutine as many times as I like now, and I'll just continually end up with that list of films from the 2016 worksheet, but that sets us up for an easier life when we write our loop to process all of the other files in that folder. Now we need to add in the code that will loop through all of the Excel files in the My Files folder and substitute in the file name for each file that we encounter. There are several ways we could do this. I'm going to rely on the dir, or the directory function, and to do that I'm going to use another variable to capture the name of the file that we're currently looking at. So let's say dim movie file name as a string, and then after I've set my file's path, I'm going to say movie file name, to find the first file, movie file name equals dir, and then open some round brackets where I can specify the path name. Now again, there's a few different techniques I can use here. I've covered this in previous videos, so I won't go into too much detail, but I want to make sure that I'm looking at Excel files in this particular folder. So I'm going to say my file's path, and then concatenate to that a search string which has an asterisk, a wildcard character, .xlsx. So that will find any Excel file, or any XLSX file I should say, in the folder stored in the MyFilesPath variable. So once I've done that, I'm just going to check that this part works by concatenating the movie file name into my, my existing connection string. So to make that work, let's get rid of the current file name, movies2016.xlsx. I need to leave in the semicolon character there. So I'll leave that concatenated to the end of that line, and then after my file's path, I can concatenate movie file name. So at this point, we're still only working with a single file, but more dynamically now because we're finding the first file in that folder. So rather than finding Movies 2016 this time, we should find Movies 2011. So if I run that subroutine again, the list of movies on the sheet now should come from 2011, so that part's working quite well. Okay, now I just need to continue finding XLSX files until I run out of files in the folder. So to do that, let's add a loop just above the connection string line. I'm going to say do until movie file name equals an empty string. So when the directory function or the dir function fails to find another file, it returns an empty string. So I'm going to carry on repeating this set of instructions until that happens. I'm then just going to highlight all of the lines of code down to the cn.close line and then tab that in one space. And after I've closed down the connection to the file that we've just copied the data from, I'm then going to try to capture the next Excel file by saying movie file name equals dir. So if we call the directory function again without passing any values to its parameters, it essentially continues the original search but at the next file. So at that point I can say loop back to the top, and it will continue to go around until we run out of Excel files. So at that point, let's just give the entire system a quick test just to check I've currently only got the 2011 movies in that workbook. If I run the subroutine at this stage, it should fairly rapidly get through the entire list of files. I appreciate there are only 6 with small volumes of data in them, but still it's pretty quick. And there we go, all the movies from 2011 to 2016. So there we go, there's the core part of the system working. We've extracted all of the data from multiple closed Excel workbooks without needing to open up a single file. But from this point on, we can get a bit more creative about exactly which set of data we retrieve from each file. If you know much about how select statements work in SQL, you may already have some ideas here about how we could alter the list of data we retrieve by adding a where clause to the select statement. So as a first quick simple example, let's say we wanted to retrieve only those films where the Oscar wins value was greater than 0. So we only want to see the films that won an Oscar. To do that, in the select statement, we can add a where clause to the end. So we're going to say where, and then we can say Oscar wins. Now to refer to the column name, we need to be careful to check whether there's a space in the column name. If there is a space in the column name, we need to enclose the column name in some square brackets. You can always enclose column names in square brackets, so as a matter of course you might prefer to do this anyway, but in this case it's absolutely necessary. So Oscar wins greater than 0. Having done that, let's run the subroutine again, and we should find a much smaller list this time only the Oscar winning films from that collection of files. We can add multiple criteria to the same query. So let's say we wanted to show only the Oscar-winning animation films. So we could also check the contents or the value of the genre field. To do that, we can head back to the VB editor, and to add another criterion to the end of the where clause, we need to decide whether it's an or an and criteria. Just like in VBA, an or criteria, if either of the conditions is met, then the answer is true. With an and condition, only if both conditions are met is the answer true. So in this case, it's definitely an and. I want to see only the Oscar-winning animation films. So I'll say and genre equals, and then to enter some text, just like we did for the extended properties in the connection string, we'll wrap these in some single quotes. So animation. Having done that, I can run the subroutine again, and this time we'll end up with an even shorter list of the 3 Oscar-winning animation films from that collection of files. So at this point, it's really all down to how much you know about SQL queries in terms of how far you can go. Just to give you one final idea, I'm going to switch back to bringing back all the movies. So I'm just going to take away the where clause from my select statement altogether. So it's back to select everything from sheet 1. Then I can run that subroutine to retrieve the full list of films. Finally, I'd like to write one criteria which excludes any film which has got the word Twilight in its title. And to do that, we can head back to the VB editor, add our where clause, and I'm going to say where title not like, and then in some single quotes, contained within a set of percentage symbols which act as the wildcard characters in SQL, the word Twilight. So at the moment, we have got the Twilight films in the title column, unfortunately, but when I run this subroutine now, I'll find that very satisfyingly, now the Twilight films have disappeared. So, if you'd like to learn a bit more about how SQL queries work and you too want to eliminate the Twilight movies from your life, you can have a quick look at this SQL Server Queries playlist. That teaches you everything you need to know about writing basic SQL queries. Gets onto some fairly complex queries by the end. If you don't have a SQL Server to play with, then you may prefer to stick to VBA, and we've got a few videos which explain how to use ADO with Microsoft Access, so there's a few extra hints and tips about writing queries in there as well. But anyway, hope you found that one useful. Feel free to ask any questions on that and I'll do my best to answer them. Thanks very much for watching. See you next time.